Good afternoon, because here in Germany it is good morning, but since most of the people I can see in China, I can see Nicole's also there. So I hope my slide is visible and also my voice is audible.
Yeah, it's fine.
Okay, thank you very much. So thank you organizers for giving this opportunity to talk in your second IIT Energy Conversion and Economics General, and it is supported by State Grid. The various dignitaries, those were in the opening remark. I saw the Vice President, Dr. Yuan, that is a State Grid ETRI, and Professor Wayne, Editor-in-Chief, and he's one of the best researcher I have seen because I know him when I was in Hong Kong Polytechnic University in 1998, and his research, etc., very high quality. The Professor Nikos, very good academician and a good researcher, and he's very much involved in IEEE activities. And I have met several occasions in the IEEE general meetings, and also I heard him for the European Commission's initiatives in the innovation and research, especially in the green technologies. Mr. Krona, the publisher of IIT, says also there are many other distinguished personalities, those are listening here. And my talk is again related to the smart terminal, multi-terminal DC microgrid control and operations. Here, the theme of this complete talk, and even though this whole event, which is going for the almost 6 hours and various panel discussion, it is basically related to the network challenges in the network distribution networks and microgrids for the carbon neutrality. Whole world is focusing that we have to go for the carbon neutral, and we have to adapt whatever the technologies are there, or if not there, why not we can invent or innovate, and then we can basically have the goal, and of that is one goal is very clear, that energy to all, and we know the UN, the SCD, the sustainable goals, already development goals are defined. Once technology are rising and developments are happening, always the development as well as the sustainability as the contradictory word. In that, we should basically see our development at the same pace, and also we have to make the sustainable system. And the energy, as you know, this is a very, very important topic, and we need that energy should be sustainable. And the nature has given a lot of things to us, and it is distributed across the globe. It is not confined to limited places, especially the natural resources. No doubt we can have the fossil fuels are the localized at the various places, but the sun and wind are almost all across the globe, and that is there. So reaching to the local people, or maybe those are not having well and strong grid connections, then the microgrid is another option. We all know that most of the problems, even though it is talked by Nikos also, that the distribution is basically from many, many years, it was not very much attended. However, we were talking about the generation and the transmission. Now the time has come and we are focusing mostly now in the distribution system and also giving the power to everybody. So then the question arises, if you're going for microgrid where we are having the weak interconnections from the available EHV grid, then how to operate? And to trap the renewable energy sources, we need basically this microgrid. That's why the question is start. Why we need a microgrid? The limited transmission capacity we know, because our funds are limited, our resources are limited, and expansion is not as fast as the load increase, and the requirement, which is the people, the living standards are increasing. Loads are not limited to now industries. Earlier, the major portion was the load for the industry, then the commercial, and then the distribution businesses or distribution sectors. But it is now it is a limited. It's not limited, and it's growing at a very high pace, and we have to add the generations. And once we are adding the generations, then the renewable energy sources is the obvious choice to have the carbon neutrality. You can connect this renewable energy sources at the high voltage, and a lot of the problems like the protection issue, the frequency variations, as you know, the low inertia concept, many issues are related with the renewable energy sources. But you can connect with the small systems low voltage system, low power system very easily and efficiently you can utilize, and it can basically minimize your T&D losses. It can improve the reliability and many other things that is possible. So, and it is cheap as well because it is available locally. So the choice is that we can have a small grid that is known as the microgrid, especially that we can trap the renewable energy sources, and those are available everywhere. So, the renewable energy sources during the last few years, the fast development and the deployment of the renewable energy sources have created increased interest because many things. No doubt the growth is one. Fast depletion and and the prices of the fuel, fossil fuel is rising. And due to the rise, it is very difficult to basically meet our energy requirement. And the limitation of earth resources. Environmental degradation is another concern, and emergence of the electricity market. So this market is there, so everyone is trying their business so that they can run in the economical way. No doubt the power electronics has given a lot of opportunity to everybody, and that's why we are moving very fast in the renewable energy sources and also to control the devices in very fast manner. These power electronics devices, no doubt, they're very excellent for the control and improving the performance, but at the same time, they are basically, it is giving a lot of other challenges to we researchers. And that's why the various type of the converters, various type of their control philosophy are proposed here. Utilizing the converter, people say a smart inverter can even to give you reactive support, along with also if you're connecting the fuel photovoltaic system. So just the renewable energy sources with the various distributed energy sources, is including the wind turbine, solar photovoltaic, as well as the fuel cells, micro turbine, many small devices we can add, and we can meet our energy demands locally, and that is the efficient way of operation. So the advantages, there's the lot of advantages we can list, and that is there. That is include it encourages the usage of renewable energy sources due to reduction of the CO2 emissions. It is easy interconnections of renewable energy sources at the low voltage, because our converters, if you are going for the high voltage rating and you are connecting with the high grade, the cost will be very high and associated losses and also will be there. But finally, our utilization is a low voltage. So it is a possible you can have the low voltage renewable sources and directly you can connect with your DC grid and then microgrid where you can utilize its benefit. And it is giving the energy crisis answers, and also it is more reliable. As I said, if you're having the weak interconnections from the many places, and that is basically it is an interconnection of the renewable energy sources, which is not very reliable because some weak interconnections are there, and the reliability of the electricity or continuity of electricity will be very poor. So it has a very high flexibility and the controllability with the help of the power electronics devices. No doubt the power generation is intermittent in nature, especially in the renewable energy sources, but having the power electronics control and having some forecasting tool, we are even able to manage the microgrid very efficiently. Microgrids reducing the T&D requirements and the T&D losses. Thereby, it is improving the efficiency of the operation, and both you can say in the distribution network, and that is one of the best way. Another, most of the AC power, as you know, in the distribution system is going unidirectional from the source to end. But it is we can have the microgrid, it is a bidirectional power flow, because you can generate or integrate the renewable energy sources wherever it is possible. And then the bidirectional power flow, and it's a control philosophy. If you are going for the normal AC control, it will be very difficult, because sometimes we are having the very cheap protection system, or you can say low cost protection system. But with the help of the power electronics devices where the converters are there, we can basically do it very well. If you are having enough power generations, you can sell to the, or you can bank to the power grid. And whenever you require, so you can do, because these are the intermittent natures. Its availability is limited at certain times, like solar, it's the daytime only. Wind, once wind is flowing. So all the things are there, but if you are having enough, so you can have sell and buy, and that's also giving the advantage of microgrids. In case of grid failure, the microgrid can supply. Suppose you are connected with the grid, the weak grid, and this weak grid is off, then you can having, if the resources in your microgrid, you can meet some essential loads. There is a possibility that your microgrid is self-sufficient, that it is having the enough energy resources where you can meet our fully demand. Then of course, at that time you can control properly. But there are possibility that microgrid will not have enough generation at certain time, then you have to take or import the power from the grid. So, but even though that is a fail, but you are having the management properly, you can meet your energy requirement up to a certain extent, and also you can have the reliability. Now we have moved and we know that we can go for the microgrid. Now question starts, which type of microgrid? There is, we are having the many resource generations in the renewable energy sources. They are the DC. We are having AC also, the like wind, you are having the doubly fed induction generators. They are basically the AC, they are connected. But like fuel cells, photovoltaics, batteries, so they are basically the DC. Even the hydrogen energy, it is connected to the fuel cells. But AC also you are having. Your utilization side, earlier we were using mostly the AC. But nowadays you can say with the help of the power electronics, your computers, your charger, your UPS, everything is now DC. So the why not we can have, so the conversion once you require, then transformer and along with others converging devices are required. So the control always asks whether we should go for the AC or DC. If you are having existing system, we may prefer to AC. But if you are going for the new microgrid, why not we can have the DC? And wherever you require the AC power or small purposes, you can use. Then the question starts the control philosophy. Who will be controlling voltage of the system? Who will be controlling the power of the system? Power means control, correct? So that's all the control philosophy must be there. Which device will be there? Because it is not there, let's say, you know, the energy or power is balanced all the time. And it is balanced, so that control philosophy must be very, very accurate. If there is a system disturbance, if there is a fault, how to protect that fault and also without interrupting the power of our end users. And that is the philosophy, must be very clearly. So I'll be giving one example in my presentation where we can see that's some examples I'll quote and we'll find it. Another problem here is giving a lot of business opportunities. And a lot of, even though companies, NGOs, they are coming forward and to giving the power in the rural areas or remotely placed people, hilly peoples, where it's very difficult to provide the reliable grid to them and power connection from there. So there is a business-oriented concept is there. So we have to see that it should be not, you know, extracted money from the end users. It should having the equal playing field should be there so that we can minimize the revenue transfer from end user to the resource generation side, and that is also required. It has a, since it is a time management every time, this we are just giving energy, etc. It is not a flat rate because the availability of the energy is different, the prices may be different. So we require large data handling and the information security is treated. And that is also the whole system where the IP-based controls are there and everything. So our system, which is a physical system, is basically very prone to the cyber crimes. So our system becomes a CPS, the cyber physical systems. And then control is very, very, because any person is just creating, you know, electricity, very special commodity. If anyone is creating a problem, what will happen? It will be basically interrupted. And it may be whole grid will be failed, not even the only one user will be affected. And that is basically one of the big things that's nowadays people are doing a lot of research in these areas in the CPS side. You are having the communication system that should be the cost effective as well. It's not that you can put the cost in here. Variety of the communication systems are available, which is economical for our electrical grids. There's a lot of problem in the line of sites and many, many issues are there and people are talking this. Another is the forecasting. Yes, we were doing the forecasting from very beginning, especially when the power system was growing. The load forecasting from very, very beginning because we were ready our generators to meet the demand and the load frequency control, we all know where the frequency should be maintained. Now it is not only load, now we are talking about the forecasting of the renewable energy sources, forecasting of your price, forecasting of your ancillary services. So that has gone and we require very fast. The forecasting of the nature is very, very difficult because it has no seasonalities, a lot of variation and intermittencies are there. So we are forecasting, no doubt, we have reached a certain accuracy in all the forecasting approaches, but still people are talking and working so that we can have a good forecaster. If you are having a good forecaster, you can manage your power system very efficiently. And that is a lot of people are working on that. The demand response, as we know, the electricity end users, are not very responsive to the price, and they are very not elastic, they are almost inelastic. So that's basically utilized by the utility side, and they raise the prices and get a lot of money from the end users to their generation side. So it is basically the demand response approaches should be there, and customers should come forward for this. Many appliances, they can defer their loads. They like charging, like washing, like cooling, many things that can be deferred with a certain interval of the time. And the demand response must be utilized, even though increasing the reliability of the system many times. So we require the fast analysis tools, all the load flow, short circuit, stability, everything we were doing. Again, here in this market, along with the renewable energy sources, along with the power electronics devices, their analysis is slightly typical, and that should be done properly with the fast analytical tools. Integrate, already I said, in the microgrid, we can integrate very easily. Now, again, still there is a concept at what voltage to operate your microgrid, at what voltage you are going to connect the various devices. So that is also the integration, and it's related to the grid codes. That suppose there is a disturbance in the system, what will happen to those generating resources? They should be disconnected or they should support the system. So a lot of the grid codes are basically being implemented in the many developed countries and developing countries, and that is basically the need of the hour. We have to see the reliability, how much we are reliable our grid, and the power quality, and many more challenges and issues are basically in the market, in the microgrid related issue. So in microgrids, various components that we know, it is microgrid is a small scale power supply network, provides the power to all the community in the size of few megawatts or MVAs. It should have the many things like renewable energy sources, I said. It may have the energy storage. If it is not having, then your operation may not be very better. You should have the power electronics devices, because AC-DC conversion or AC-AC converter, or even the voltage boost up, etc. is required. So the converter is controlled. You may have the variety of loads, AC and DC, and that is also connected. And you are having a small distribution network as well. Its operating mode can be your islanded mode, or it can be your grid connected mode, because many places the grid is not accessible and it's not available. So then islanded mode of operations people are doing. So in that, energy management is very typical. But if you're having grid connected, if your resources are not there at that time, you can take power supply to the grid, or you can send it back to the grid if you are having excess of energy in your system. So that's in the both mode of the operations are existing in the across the globe. And based on that, the people should realize and manage the grids according to that one. So the opportunities of microgrid and its classification, it offers the opportunity of the electrification in all the remote rural areas where as I already talking, that the grid interconnections is not very fair. It's not very easy possible. It differs from many construction of the new transmission line and the distribution lines, because you can generate locally. It is always said that if you are generating 1 megawatt locally, then it is impact is basically more than 1 megawatt is a far off generations, because due to the line, due to the constraints of the limitation of the line, etc. that is there. And of course, it's creating a lot of job opportunities in the niche areas of the technologies. A lot of technologies are coming for all this, for control and the philosophy, etc. And it is reducing the dependency on the fuel. And it can be AC microgrid or the DC microgrid. Already I said AC and DC. And the two both architectures I'll be showing in the next slide. You can say this is an architecture of AC microgrid, where you can say there's wind here. We are having the wind generation, and that is the AC power along with the transformer. You can say here, if the voltage is AC microgrid is a 415 volt, it's a 3-phase RMS value. Whatever the voltage in your country, it depends upon that. So this is the AC power which is destroyed. You can have the PV cell, the photovoltaic, and you can say it is, you are having the boost conversion, and then you require the inverter if you are having the AC here. So it is a DC to DC converter to increase, because this PV, the PV the generation voltage is very low. So we require the boost converter, the DC to DC converter, and from there we are having the DC to AC, because it has a lot of advantage of having this. You are having the fuel cells, it may be the solid oxides and other things. Here also you require that it is generating the DC power, and you can say also you are the DC and the AC you are converting and you are connecting here. You are having battery energy storage system, so the power can come and go, because it can store, it can discharge, and we can have again your DC to AC conversion here is possible. We can have our AC to DC loads, then we can have the rectifiers here. We can have even though AC loads, 3-phase or single phase. So it's a variety of this, and you can have even the grid connection if it is there. Islanded or grid connected modes are the 3-phase loads, etc. there. So the variety of the things configuration you can say here, but the grid is known as AC grid because the interconnection points from all the sources, it is the AC. But if you go for the DC, you can see here, this is my AC generations, or the doubly fed injection generator. It is a permanent magnet generator, synchronous generators, which can generate the DC of the rectification, but we can convert by the, again, AC. So normally it is a full converter ratings are required, and you can say here the rectifier is needed, and this is going in the power pool and is known energy pool. We are having the PV directly, we are connecting the DC, no doubt we are having the boost converters to at this voltage level, and it is chosen the 750 volt. This fuel cells also you can say DC, batteries also DC, and the loads may be AC and DC. If you are having the AC interconnections, then you require here voltage source inverters, and this DC to AC here is connected. But various loads here, the DC, AC, just you can connect it with the converter inverters, and finally you can meet this is the architecture of DC microgrid. So advantage of the DC microgrid over the AC microgrid, thus DC MG is preferred over the SMG because of several advantages such as a high quality power supply, better reliability and uninterruptible power supply, better utilizations, which reduces the total loss due to the non-availability. It's not requirement of the reactive power. As you know, the active power flows, both active power flows, it requires reactive power along with the supports of that. So that's why this is a very high efficiency and easier control of the DC units connected to the only the DC voltage control is required. No synchronizations, only you require the synchronization if you are having the AC grades. And it is also reducing the corona, although it's lower volt corona doesn't exist, but the skin effect, etc., can be minimized here. So the DC is required. So, but there are challenges in the DC microgrid is controlling the DC microgrid voltage with the pool. So a control strategies are required that who will be controlling the board. Like here in this, so who is controlling this voltage and who is controlling the power balance here? So in this study, what we have done is the wind turbine is taken as to controlling the voltage and others are controlling the energy. So based on that concept here, and it requires more space if you are having the battery banks, if energy storage devices you are having. The synchronization of DCMG with the utility grid is there. So is the synchronization panels required and control philosophy must be utilized. And another is the protection issue. Because the DC protection is difficult than AC protection. But in the DC protection, the converter itself used as a protection system. And they are basically controlling in such a way that if there is any fault, they can assess and they can control, just like in high voltage DC transmission system. So in the present study, I'll show some of the results to you in the 5 minutes, 5-10 minutes are already the time which is allotted to me. The proposed structures, I've used the here microgrid and facilitated the connection by the DGSS various webcam. Here the DC microgrid is available here, where both type of the loads are there, which is can be connected and eliminate the need of transformer. So all these features of the proposed here that we have used, and you can see that's when the control philosophy, as I said, is a very, very important who is controlling what. So when the wind turbine generation is 0 or less than the 3-phase load, which is connected in the local area, then this load is supplied by other sources through the bidirectional switch. So you can see here in the DC grid, if this power is 0 and we have a 3-phase load here, so that's why it's a bidirectional here. Things are there. The switch is bidirectional. So the power can flow to this load, and many a times load can be utilized locally. So this basically control philosophy, and this is controlling the voltage of here. So that's and the power balance is basically used. So you can say that we are having the two bidirectional here. This is a battery, your this wind, and your AC grids. Remaining, you can say this is a unidirectional. It is maybe 0 or it may be its value, controllable value, which is there. We have used the fuel cells, power generation, and its variation and loads, etc. It's basically the output and other things are controlled, because this is used as a fuel cells is the last option, because we have to see if power is very less and it is our battery is not able to meet, then the fuel cells are turned on, and otherwise it will be off most of the time. So it's a variation according to the load and the generation availability, and I'll be talking with some of the cases that you can find. So the battery energy strategy is reduce the control of the power balance, and that is in the islanded mode, it is also taking care of all the things. So the voltage source converter based DC MG is proposed. I'm not going to talk about the voltage source converter. We all know the voltage source converters are better than the current source converters because normal HVDC it is used. But with the help of the low voltage applications, we can go for the voltage source converter. It is just like we can operate whole DC system like a AC system. Means we can control the current, etc. So the proposed control strategy for the bidirectional voltage source integration of the wind generators already I said in our DC microgrid. You can see this is our control, the voltage source converter, and the power is coming from the sides, and this it is connected to the grid here, the DC voltage. So the various things are here. You can say, well, the modulation control is controlled by a certain philosophy. We are basically having, it is a synchronous frame of reference where the PI controllers are used. I'm not going to talk much about this, but this control philosophy we have used, and we have published this paper in one of the transactions. So you can see the objective of this control strategy is to establish the constant DC voltage of the DC microgrid under the various operating conditions, it's a normal and your fault conditions. It maintains the power of the three-phase load in the local area of wind power generation. And when it is a 0 or less, then it is we are taking power from the grid. The proposed strategy has been implemented in the rotating synchronous frame reference. And here we are using the positive SRF and the negative SRF concept is used to control effectively in this microgrid. So the controller of the DC-DC here, boost converters of SPC, and also been proposed here in this our reference, that is in general meeting 2012. To show some of the examples of the synchronous frame reference concept that's controlling our wind turbine as a voltage, and the remaining are controlling in the power balance mode, like your fuel cells and your photovoltaic. These are the various things we have used. You can say the wind turbine capacity is 600 kilowatt, 690 volt. The SPV is 100 kilowatt. Fuel cells is 100 kilowatt. And it's a peak power capacity of here is 1 kilowatt. Transformer we are using for the wind turbine, it is of this capacity, 1.5, 25% more than this capacity that we have taken here. And the various wide directional, here the source here, because the 600 power is giving, so is again, it is higher because of certain emergency, certain rise, etc. that is there. And the load side, we have various loads. We are having the three-phase loads. We are having the 100 kilowatt loads across the three-phase, here operating at 450 volt. Here the 2 kilowatt loads of the single phase, here operating at 240 volt, because signal is a three-phase, as we all know. We are having the DC loads as well. We are having some electric vehicle loads at 500 volts of 100 kilowatt. So the total load here is a 600. So now with this generation capacity and this, we are trying to control the different philosophy. And you can see the various cases are taken. And that is the variable generation and constantly. If load is constant and our generation like wind power, you can say changing, then how our this power is going to change, and how our, if the PV is changing like this, wind is changing that, then what will be the fuel cells here in this case? And you can see this is the variation based on the total demand here. So you'll find the voltage of the DC microgrid, how it is controlling in all the variation of generation, the voltage is maintained at 760 volt. So that control philosophy here. You can see the total load is a variation like this. This is a case 2, where the generation here by these two are constant, but the load is varying. Your load is changing. Now you can see our fuel cells must follow this, because our wind power as well as the solar is a constant. So that minus the load will be coming from this one. So the power generation is here is rated, you can say. So this variation is exactly following, but the voltage control is always there, and which is we are doing. In case 3, everything is varying. That's we are having even the battery also. And then you can say the battery, that is you can say fuel cells, your wind power here is there. So the total here, you can say, if our load is in the blue line, the total power generation is the dotted line here, you can see. So the battery power, how it will be managing, if the more generation is there, the battery will be charging or it is discharging. So the battery concept is also philosophy is used when it will be doing, when the fuel cells will be coming, what is the generation capacity. So in all the cases, you'll find the voltage is maintained. And that is, you can say, the beyond the generation capacity of here. the mismatch between total generation is fulfilled by the battery sources. So battery is only taking when all things are exhausted and it is a charging and discharging concepts are there. But you can another philosophy, because many control philosophy can be used. And here, based on that, the various here the results are found. Another we found that it is the electric vehicles here, not electric vehicles here, the electric battery storage system was used. But nowadays, the hydrogen storage energy is very prominent all across the globe. And then people are talking, why not we can take the hydrogen energy, we can generate the hydrogen energy, and this is also another type of storage. So that's a hybrid energy storage system in the DC microgrid it's proposed. And using this only changes instead of the battery energy storage system, along with that we have done. So the control philosophy of these two are very important. When it will be charging, when this will be hydrogen will be produced, or from hydrogen energy we can take it back to power generations, and here the converter. So this energy storage, because the hydrogen is used for the fuel cells, and that fuel cells is again used generate the DC power along, and this is connected here. So that's a concept is also tried, and this is a control philosophy of hydrogen and the battery energy sources that is a very important. When the battery will be charging, when hydrogen will be charging, and that's basically this control algos is developed, and it was tried, and it was found that it is working well. So it is you can see here the balancing power is complete this philosophy. The purpose of the proposed control strategy is to control the charging and discharging of the battery to its full capacity, and thereafter store the generator surplus power in the hydrogen energy system. And in various cases we did, along with the here residential load curve, and you can see this is the various, we did the SOFCs and other things find here, and you can find this the battery voltage here is how it is varying during the charging and the discharging here, the battery output you can see here. So the various cases here, the generation and the is variable, and the load is also variable. Already we did like this. And once here, you can see this is a hydrogen energy here. It is based on the electrolyte which we have used. So when it is enough surplus energy is there in the system, you can say the hydrogen energies are produced. Otherwise, it is stopping. Here we have not taken that hydrogen energy to get it back with the fuel cells, because the fuel cells is a different one, but that hydrogen can be used back in the fuel cells, and that can generate. So that we have not used, only we are saying we are producing the hydrogen, and that can be kept the storage. Whenever it is required, it can be put in the fuel cells and so on and so forth. So this is basically the various cases if the fault is there, because not only normal conditions, not only changes in the load variations and generation variation, but there is a single phase fault or the three phase fault, what the variation, how your control algorithm is coming. So that is also tested, and based on that, you can say it is a line to ground fault we have tested for the 0.2 seconds. And you'll see our system is taking care of completely, you can say, the load of telecoms, etc. You can say here, we are having the total generation here, and hydrogen also, you can say it is generating is a various capacity, because our battery voltage and other things are happening here. So this is discharging here, it is discharge, and finally you can say zero, because the zero output here. So it all depends upon the concept which is separate. So to conclude, because already I took the 35 minutes, the DC microgrid facilitates the connections of any type of the renewable energy sources, energy storage system, the variation of the AC and DC, the three-phase loads, and it can have the pulse width modulation power electronics converter, that is the VSC, can be very easily incorporated in the low voltage side. DC microgrid is able to supply both AC and DC powers simultaneously by high quality of the power. Already we checked the harmonics and other things. It's good because pulse width modulation we are using. The DC microgrid can operate in both islanded and the grid modes of operations. And DC microgrid offers the opportunity for the electrification in the remote area, which is very important. The DC microgrid with the sustainable control strategy operates satisfactorily under the various operating scenario. You need to fail, fault, and also in the transient cases where we can see. The circulating current was one of the concepts many generations are happening. So there is a possibility that the circulating current will flowing that can be very effectively controlled by autonomous control. The DC microgrid where it should not have the circulating, because one is generating, another is charging. It should be going to the load ends. So the need of the transformer has also been eliminated at the various places. Whenever you are having AC-DC conversion of the loads and power, that is required, but in many cases, only the BSC control voltages can be used, and that is there. So with this, thank you very much. And if you have any questions, certainly I'll be happy to answer. Thank you.